Hi, it's Derek from Tomcat Gas Training, and has this ever happened to one of the plug sockets in your house? Well, if it has, I'm going to tell you why it's happened and how we're going to change the socket. So, let's stop waffling and messing around and let's get on with it. Now, why has this socket melted? Well, there could be a few reasons why it has. First one could be the plug could have a loose connector on the neutral, and that could create the heat which can melt the plastic. And you can see on the plug top here that it's pretty charred, but this is a moulded plug, so it's very unlikely that the wire has come off on the inside. So it could be the neutral wire actually connected to the socket could be loose and has created the heat. But normally when it does that is it melts it from the inside out, not the outside in. So it's going to be interesting once we get this socket off to see exactly what has happened. Now, my thoughts on this is that one of the trainees has got this plug wet. They've then plugged it in but not plugged it in all the way, and it's somehow created a load of heat and it's melted it. So it is going to be interesting to see how this has happened. So, first thing we need to do is have a look at the tools we're going to require to be able to change this socket. First thing is, let's have a look at the screwdrivers. So we're going to be needing a flat bladed electrical screwdriver for this. This is no good because it's not protecting us from getting electrocuted. So if you put your finger like that and then put it into the socket and you haven't isolated the supply properly, you're going to get electrocuted. So that one, don't use. So we're going to be needing a rated screwdriver, and this is rated to 1000 volts. So this is the kind of screwdriver you need. This is just a cheap pack side set from Lidl. Now, you could also use one of these for the screwdriver, but we're going to need some way of testing the power has gone off. You don't want to be using one of these for testing the power's gone off. So don't use one of those either. So the way we are going to be testing whether the power's off is we could be using one of these socket testers. So I've got two different types here. This is a cheap one which doesn't do an earth loop impedance test, but this one from Socket and C does. So we're going to be using that. You could also use one of these, which is a non-contact voltage indicator. So this could be telling us whether the supply is live or not. But we need to prove this is working first, then use it, then prove it again. That means we need an electrical supply, and if we've got the power off, we can't use one of those. So we could either use this tester, which actually tells you what the voltage is. You don't have to set the range. This will automatically do it for us, and I would advise one of these, or we could actually use a multimeter, but we do have to set the range on this, so you could actually make mistakes. So we're not going to use that, we're not going to use that, and we're not going to use that. I'm not throwing them though. So the tools we are going to be using is this tool pull tester, but we'll need to use a proving unit to make sure it's working first. Then we can test it's dead and then we can use it again. We're going to be using this socket tester, and we're going to be using this electrical screwdriver rated to 1000 volts. That's the tools. Let's get on with the job. Now, I think the first step is pretty obvious. We've got to isolate the electrical supply. So what I'm going to do is, I'm going to plug this in, turn this on, and you can see it's testing whether our live, neutral and earth is correct, and it's doing our earth loop impedance test. And it's going to do this continuous buzzing. So what I've got to do now is, hang on a sec, because we don't want that going off in the background while I'm talking to you. So what I've got to do now is leave this on, find the fuse box or the consumer unit. We've got a fuse box under here, under this unit here. So we're going to isolate the fuse board, we're going to leave our socket tester running, we're going to isolate, we're going to remove the fuse, and then we're going to turn the power back on because we need the lights, but without the fuse in for the sockets. That should stop buzzing. We're then going to remove the front and then make sure it is isolated. I'll show you that in a minute. So let's get to this fuse board. So here we are at our little mini fuse board. Yours will be a lot bigger than this in your house, and you could have a consumer unit. You should be able to still hear the little buzzer going. So first thing I need to do is take this cover off. I've undone this screw a little bit, but I'll need to turn the power off first. So you can hear the buzzers stopped now and the lights have gone off. So I need to remove this. So you can see the fuses are marked here, which it says lights and sockets. We need to remove the socket one. So that, and I need to retain this fuse because I don't want anybody plugging it back in, and you can see it says sockets on it. I can now put my cover back on and turn the power back on. The lights have come back on, but the buzzing has stopped. So hopefully now that socket is dead and we can remove it. You could also have a consumer unit like this one. So you can see it's marked up lights and sockets. So if we want to take the sockets off, we can lift the lid up. This is a MCB or a miniature circuit breaker. This is an RCD or residual current device. So we need to put that down. That will turn our sockets off. We can then put some tape over it because hopefully nobody's going to turn it back on if we do that. We can then close the lid and we can even put a sign on it. And then hopefully nobody's going to turn it on. There are also special locks and special padlocks you can buy, but hopefully that is good enough, seeing as I am the only one here. So you can see the lights have stopped on the socket tester. We've not got the buzzing. I've put a towel down on top of the worktop just to protect it a little bit, so I can now remove this. Next thing I need to do is undo the two screws here. We need to retain these screws, so I'll put them up here somewhere safe. So we can remove the socket now carefully, pulling it towards us, and I can now see if any of the wires have melted or fallen out. So I think you can see neither of the wires have melted, and there seems to be no damage to the socket on the inside at all. And you can see the colours of the wires now. So this green and yellow one you can see here is the earth wire. This blue is the neutral and the brown is the live. Now you may have black wires instead of blue and red wires instead of the brown. These are the European colours for wires and were changed quite a few years ago. But it doesn't matter if you've got the black and the red, they're still neutral would be black and live would be red. So first thing I'm going to do now is test that the power supply is off. So I'm going to use my 2-pole tester. Now they should have little covers on here which should stop you putting your fingers on, but I've removed them to make it easier for testing in this socket and on my proving unit. So the first thing I'm going to do is just check the cables are okay and there's no nicks and it's not broken. I'm going to put the two connectors together. That's giving me a buzzing and that's telling me that the battery seems to be okay on it, but I'm just going to use my proving unit to make sure it actually is working. So I need to put my live onto this connector, my neutral onto here, and it should, when I press down, light up. So we can see these are working. So what I'm going to do is I'm going to put this black cable onto my earth connector, and I'm going to test the screw here on the live, and there should be no voltage. If it's live, I should be getting 220 to 250 volts, and I'm not getting anything. If I go between my earth and my neutral, I should have nothing anyway, and I've got continuity, so that's showing me I've got an earth between them. And if I go between my neutral and my live, I should have no voltage, and you can see I've got no voltage. So I can pretty much say this socket is dead and I can remove it. So all I've got to do now is prove that this is still working before I can use my screwdriver. So again, I need to go onto the live and I need to go onto the neutral, and you can see it's still working. So we can put that to the side now. So all I've got to do now is disconnect these 3 connections. So we'll do the earth first. That's the earth wires out the way. We can do the neutral. And that's the neutrals out the way, and we can do the live. So that's the wires disconnected, and you can see now there's a little bit of damage here, a little bit of heat damage where it's come through there. Okay, but nothing really on the inside. It must have all been from that plug. It's unlikely that it's got a loose wire inside because it's a moulded plug, so it must have been something one of the trainees did when they were plugging the kettle in. We're actually changing the way we make brews now at the centre because of this. We've actually bought a geyser, and having that fitted what gives hot water and cold water. I might do a video on that to show you what it looks like, but anyway. So let's get the new socket. Now here's the new socket. Let's get it out of its little bag. We do get new screws and new caps, so we're probably going to use those. So if we look on the back of the socket now, we can see we've got an earth connection there. We have the live connection on this one here, and we have the neutral connection down here. So that's where we've got the different connections from the other one. So that's where we're going to put our brown wire. That's where we're going to put our blue wires, and then that's where our green and yellows are going. And the socket is that way up. So when we put them in, we need to make sure it's that way. And you can see the earth is on the opposite side to where the last one was. The live is on the opposite side to the last one, and the neutral is on the opposite side to where it was on the other one. So it's important, guys, that you check and make sure on the back you can see where the live, neutral and earth is. Now before I install it, the first thing I need to do is open it up, so because the screws are screwed all the way in. So you can see they're open now. So we need to get it the right way around, and we need to get these wires in. Now the first wires I always put in are the earth wires. Let's get them in first. So make sure they're nice and tight, and then give them a pull to see if they come out. Next ones I'm going to put in are the neutral ones. Let's just move these live wires out of the way. Now when we put the wires in, we don't want any copper showing, like that. So we can now screw this back in. Again, make sure they're tight and check they're not going to come out. And then the last two we can get in are the live wires. Again, make sure no copper is showing. Make sure it's nice and tight. Give them a tug, make sure they're not loose. And then we need to bend the wires back so we can get the socket back in to the back box. Now I just nip the screws up either side first, don't just screw one in and then screw the other one in because it kind of twists the socket. We're just going to go between the two now.
And just evenly tighten them up.
So not too tight because you don't want to snap the back box. So that's pretty snug, pretty secure. So all we've got to do now is make sure the switch is turned off. We can put our socket tester back in. We can turn the power back on. We can go down, reinstate the fuse and see if it makes a buzz in. And then this will also tell us if we've wired it correctly. So power back off, lights go off now. Take the cover off, reinstate the fuse, make sure it's all the way in, and when we turn the power on now we should get the lights coming on and the buzzing. That's a good sign. Let's get this cover back on and check it's worked properly. So you can see the socket tester's worked correct. Let's just test it again in the other one. There you go. The job is as simple as that. Now if you've liked this video, why don't you give me that thumbs up or leave a constructive comment down below. If you've not subscribed to my channel, then please subscribe because it helps. And don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. Could be any day. Anyway, all I've got left to say is, thanks for listening, thanks for watching, and if you don't think you're competent enough to do this, please, please, please make sure you get an electrician who's qualified to come in and do it for you. Cheers guys, I'll catch you on the next one.